is I don't want that function value. In these, I'm trying to do slope, so in the table, I want MPQ. So what is MPQ? What's the formula or the equation going to be for it? Well, it's same old, same old. Difference of the y's over difference of the x's. Difference of the y's would be 4x minus 1/2 x cubed minus 4. Difference of those two divided by the difference of the x's, so that's x minus 2. Okay? Make sense? So that's what I'm going to plug in. Go ahead and plug that into my formula here. 4x minus 1/2 x cubed minus 4, parentheses around that, divide that by, parentheses, x minus 2. Yeah. Okay? I believe I've got it there. All right? Okay, now the question then becomes, well, what x values am I going to plug in to estimate this slope? Well, I want the x values to go to the x value that I want the slope at. So I want the x values to go towards 2. And probably look at on the left and the right. The book may tell you which ones to plug in, but if we're having to decide here, I want the x values getting closer and closer to 2. So 1.9, 1.99. 1.999 would be the ones on the left. You with me there? See where why I picked those? All right, so the table, yeah. All right, 1.9, 1.99, 1.999. Negative 1.705, negative 1.97, negative 1.998. I think I'm seeing a trend here, aren't you? Looks like those are going towards -2, aren't they? Well, just to be sure, we'd also want to look at the other side of 2. So what are we going to do there? 2.1, 2.01, 2.001. Yeah. So 2.1, 2.01. 2.001, negative 2.305, negative 2.03, negative 2.003. Those are also going towards it. So, are we ready to call it? Slope of the tangent line, -2. Think we're safe there? I think so. I think we have enough evidence there to say the slope of that tangent is going to be -2. All right, now one other part to this, maybe a couple other parts, and then we'll do one more thing, another connection. But let's go ahead and see, because one way we can check this is to graph this. Graph the function and then graph the tangent line. Okay, so if the slope of the tangent line is m equals -2, and so what is going to be the equation of, so this is part B, I guess you call it, the equation of the tangent line? Well, the way I approach lines is there's different forms of lines. You got point slope form, you got slope intercept form, standard form. We always go with the equation of lines. The tangent line is just a line. I always just say, let's look for y equals mx plus b. That's what we want. That's usually what we want anyway. So I'm looking for y equals mx plus b. Good news is, I got the m, don't I? To fill this out, I need to know the m and the b for this line to be completed. I got the m, don't I? The m is -2. All I have to do now is figure out the b, and the way I go about it is we've got this, if we go back and look at it another way, that's an x comma y, and that's on, I'm looking for the slope of the tangent line at 2, 4. So 2, 4 is on the tangent line. That's the way I've made this, is 2, 4 is going to be on the tangent line. So an x comma y on this line is 2, 4. So plug in x to be 2, y to be 4. You with me there? And that'll give me, whoops. That'll allow me to find b. So that's how I usually do it. I mean, you can use point slope form if you want to, and that's fine, but this is the way I usually do it. Well, it looks like b is 8, because you just add 4. So my equation of the tangent line, y equals negative 2x, m is negative 2, plus b, so b plus 8. Okay? All right, now, here's the ultimate check then. Let's graph the function and the tangent line here. And see if indeed it is, if that turns out to be a tangent line at 2, 4. So let's graph our function. So I have to go back in and change that, and then alongside it, let's do our tangent. So I'm going to graph those two things side by side here. So clear out the slope one. So I'll do 4x minus 1/2 x cubed. It's my y one. And then my second one is minus 2x plus 8. And cross your fingers. Hey, that looks pretty good. Of course, the x cubed graph that's one of those going up and down there. But then the line comes in, and yeah, it looks like it just comes right in at 2, 4 there, and it's like a pretty good tangent there. You see, we're seeing what we should see, so I think we did good there. Is this okay? All right. Any question? Got one more thing to show you here today. All right. Got that? That wants it. All right. There is another place, several other places we can utilize kind of this same idea, but what I'm going to show you here today is the idea of what's called instantaneous velocity. Instantaneous velocity. So the idea is, velocity, speed, rate, talking about pretty much the same things there. When we're calculating our rate, if we're trying to calculate rate, the rate at which we traveled, what we usually know is we know how far we traveled and how long it took us to get there, right? And so that way we can compute a rate, a velocity, if we're talking about speed between 2 points there. However, the thing with that is that's not instantaneous velocity. So if I'm just kind of averaging velocity, if I do it that way, I'm averaging the velocity from here at point 1 to point 2. See what I'm saying? Because I'm not actually computing an instantaneous velocity. That's not saying I'm going, say my average was 50 miles per hour from here to here. That's not saying I was going 50 every place, was it? That's the average of that velocity from here to here. I may have been going faster than 50, part of it, and slower than 50. You see what I'm saying? So it's an average velocity. What we're looking at here is there a way to compute, if we know something about, say, the distance formula, is there a way I can compute the instantaneous velocity at any particular time, at 1 second or 2 seconds or 2.5 seconds? And the answer is yes, I can do that with kind of the same idea. So, but I do start with what we technically call the average velocity. Like I said, the average velocity is what I'm looking at there. It's it's the distance traveled divided by the amount of time I've traveled. And in this particular case, what I'm going to be looking at, all right, so let's say I've got this formula, y equals 100t minus 6t squared. Okay, and so that gives me a height of an object after t in feet after t seconds. The height in feet after t seconds. Okay, so here's what I want to do. I want to know what is the velocity of the object after or at, let's say, 2 seconds. What is the velocity at 2 seconds? Well, just from that formula, I can't tell you that, well, unless we know some other stuff, but for right now, with what we know, or what we've done so far, if I plug in the 2, that's not going to give me velocity, that's going to give me height, right? So that's not, I'm not, it's not just plugging in a number here. Now I want to know the velocity. The formula gives me the height. So how do I go after this? Well, again, this is an instantaneous velocity that I'm wanting the velocity at an instant. However, what I'm going to have to use is average velocity to compute this. And so what that means is, to start this out, I'm going to have to not only take what the height is at 2 seconds, but I'm going to have to go a little further up, or back, I guess. You can back up too, but I think on these they generally go from 2 seconds, they go up. So I'm going to have to go from 2 seconds out to another number of seconds. Well, that gives me another height, and so that way I can compute the average velocity. You see what I'm saying? And so, yeah, so to find this, I'm going to compute average velocities between t equals 2. So I'm going to take, the first one's going to be t equals 2, and then t equals another, let's call it x. See what I'm saying? If I go out to another t value, call it x, okay, then I can compute this average velocity. And then we'll see where to go from that. Just kind of get the general general thinking. All right. Well, what would be then this average velocity between? So the average velocity well, again, it's distance divided by time, it's like a rate. What would be the distance that I traveled? Well, I'm going from this height up to this height. So isn't the distance I traveled the difference of the heights? Divide that by the amount of time I've traveled. Well, if I go from 2 seconds to out to another, it's just the difference of the times, you see. Well, does that look familiar? If you think about it, what are the heights? They're y values. And the time values, well, we're calling them t or x, but it's basically the difference of the y's over difference of the times, difference of the t's. It's the very same thing we were just doing. It's like slope, you see, so it's very, very analogous. All right, now, so the difference of the heights, you can call, the second one, so here's what I've got. Again, I've got basically 2 points. I've got 1t equals 2, so that would be what, 200 minus 24, is that right? Which is 76. And then, well, let's call the second one x, and then it'd be 100x minus, you can use x or t here, it doesn't matter. But. So that's time and height, that's time, and then height of the second one. It's very, very much the same thing. This average velocity is then difference of the height, so I just take the difference of the y's. Over difference of the x's. Or difference of the times. Pretty much just like we were doing. Okay. So I've got a different answer on it. I changed my formula up. So. All right. That's okay. All right. Okay, so how, that gives me average velocity though, so how am I going to get instantaneous velocity? Well, I'm just going to set up a table here. Where the y value is going to be this average velocity. So it's that. And then I want to get the instantaneous velocity at 2, so do very much the same thing that I did previously. I want my x values here closer and closer into 2, aren't I? Now, one thing they kind of do different on this in the book anyway, is they list it a couple of different ways, so they don't necessarily give you the x value. They'll either give you a time period or a time interval. And so you have to kind of figure out about what they give you, what the x value is. All right, so let's say we have a time period of 1 second. What would be the x value here that they're looking at? Well, I'm starting at 2 seconds, so if I do a time period of 1 second, that's going out to x is 3, right? See what I'm saying? Because the x value I'm starting at is 2 seconds. So they want us to go 1 second beyond that. So the x value for our formula would be 3. The other way they'll do it is a time interval. So let's say that the next time interval, so that would be a time interval of 2 to 3. And then let's say the next time interval I want 2 to 2.5. So the x value there is 2.5. So yeah, they kind of give it strangely, and of course the time period there would be 0.5. So you kind of have to figure out from what they give you what the x value is. And, the idea is the same though, because notice here I'm doing the x values getting closer and closer into 2. I started at 3 and went to 2.5, and so the next one, let's say I do a time period of 0.1, so that'd be a 2.1, and then a 2.01, so that'd be a 2. It's the very same idea. I'm getting closer and closer to that x value, the time that I started at is 2. Is that okay? All right, finishing up here. So then, what I would do is plug that, if you figure out this difference of the heights over difference of the times, just plug that in the calculator and let it do your work for you there. Sure put parentheses around it though. Graph just in the table. Okay, so 3, 2.5, 2.1, 2.01. Ooh, that's not good. What did I do wrong? I got something wrong here. Because this is going to infinity. Is this is the right number? 76? No, that's not the right number. Okay. What is this number? Should be 100 times 2 minus 24. So it's 200 minus 24. 176. Is that right? 176. That makes a difference. Yes. Yes, it does. All right, so that's 70, 73, 75.4, 75.94. Yeah. I think we can see there that our average velocities, those are tending towards 76? 76. I believe so. Okay, so that would be, so whatever those are going towards then, that's our, what is the velocity at 2 seconds? That's our instantaneous velocity at 2 seconds. It's not an average velocity, it's not averaging anything. That is precisely, based on this model here, that's the velocity, instantaneous velocity, if you will, at 2 seconds. What is that? Feet per second? So yeah, because I said the height was in feet, so it'd be feet per second. Okay?